Hello students, how are you? I hope you are in pink of health in midst of this coronavirus pandemic and you are not only protecting yourself and your family and as responsible medical students, my students, I'm sure you are making wise decisions to stay at home and following all the precautions which are given by the government of India and the state government of Tamil Nadu. Yeah, by the meantime, the study should go on. So we have started this series of lecture series on infectious diseases, and we will be continuing for the fourth semester. So let us start our presentation. You always know that I always start my presentations with a trivia, a fact, or a code. So if you can guess that how many of human beings have ever lived on this planet. So it calculates, one estimate says that it's about 108 billion of human beings who have ever lived on this planet. And out of them, we are just 7% present now. And it is this 7.3 billion people are responsible for something called as globalization 4.0. What is globalization 4.0 is something related to trade, environment, global value chains, global trade architectures, international investment and trade facilitation, and blah blah lot of things. This is happens. In all these architectures, are you able to find anything relating to health? You're not able to find anything health. Yeah, are you able to find anything which is permanently related to climate change or adding anything to the social aspect of health? Nothing. That is why when this virus comes and all these things gets disrupted. So when coronavirus has hit the human kind, it has led to disruption of globalization 4.0. The whole economic growth which we had for the last 10 years was stupendous economic growth has gone in a toss because of coronavirus, this pandemic, and it emphasizes on the need to invest in public health. With this short introduction, we will start with the topic of today, which is influenza. I will be covering, and in fact, just not only the influenza which affects, but one of the most important pandemics and epidemics which have occurred, H5N1 and N1. So, I am Dr. Joseph Suryavanshi, Associate Professor in Environmental Medicine. We'll start with our presentation. So the objective of the lecture will be to describe the important agent, host, and environmental factors affecting influenza and describe the preventive and the control measures which are for influenza. We will be going fast in this case because most of you people know a lot of things about influenza. So we'll try to define what is influenza. It's an acute respiratory tract infection caused by influenza viruses of three subtypes A, B, and C. Only known pandemics are caused by influenza A virus. It's a disease which is characterized by sudden onset of fever, chills, malaise, muscular pains, cough with negligible mortality, but can be prevented by following respiratory, execute, and vaccination. So the problem statement is it's truly an international disease. It occurs in all countries, affects millions of populations, and during the inter-pandemic period. So we'll be showing you that what are the pandemics of influenza which were caused. During the inter-pandemic period, there are something called as annual epidemics which occur. That estimated to be about 3.5 million cases of severe illness and about 2.5 to 5 lakh deaths every year. Every 10 years to 40 years, there is a pandemic which happens due to a major antigen shift in in the influenza virus. So this is the problem statement, which is somewhat blurry, but you can able to make out that in India, because in India we have mostly the influenza B virus, which is much more prevalent, and the H1N1 virus. Okay, the A virus. Globally, and look in other countries like China, where there is a predominance of the A virus or H1N1 virus, there is high percentage of pandemic. Okay, If we see the history of the influenza pandemics, starting from date we started recording this pandemics, you can see the Russian flu, which lasted for 1 year since 1889, caused 1 million deaths with a case fatality rate of 0.115 with a subtype of H3N2. So by the time you know what is H3N2, it is heme agglutinin 3 and neuraminidase 2. Okay, I think it's covered in your microbiology chapters. You can read more about it in the microbiology. But what is much more dreadful is something called as the Spanish flu, which happened in 1980s and which had killed 20 to 100 million people. So that is a very big estimate. So 2 crores to 10 crores with a case fatality of 2 per percent. And people have started comparing this coronavirus epidemic to the pandemic which happened. Mind you, the causative agent of COVID-19 is coronavirus and influenza is an H1N1. These are the two different viruses. Okay, both. This is the first time that it is coronavirus is causing a pandemic spread after SARS. Looking then, there's an Asian influenza which happened in 1971-78 with a case fatality of 0.13, a Hong Kong flu pandemic which happened in 68-69 with a case fatality rate of 0.1, and 2019 with the flu pandemic which happened with more than 1,000 deaths called as H1N1 with a case fatality of very 0.03. So yeah, I have personally worked under in H1N1. So this is the second pandemic which I am working under. Okay. Here we can see that there's a distribution of these subtypes of viruses which are known to cause. So as we know that influenza A is the one which causes the subtypes H1N1 and H3N2 are the most common cause of causing the pandemics. The B do not cause pandemics. So we are very lucky to have influenza B virus in India, which prevents the cause of a pandemic. What are these unique features about these influenza epidemics? They arise suddenly, they arise with very fast, they spread very fast because the incubation period is short. And not only that, give rise to a lot of subclinical cases with high proportion of susceptible population, which have a short duration of immunity and an absence of cross immunity among the different viruses. What is the meaning of absence of cross immunity? That uh, it means that you will not be, if you are infected with influenza B, you will not be immune to influenza A. If you are infected with influenza A, you will not be immune to influenza C. That it means that the absence of cross immunity is a one which causes a lot of morbidity on the human population. So what are the phases of pandemic? I think you should know about this in this thing. So that's why I just put this slide. So the phases 1 to 3 of a pandemic are predominantly animal infections with few human infections. So if India is still in this phase of local transmission, what is called, and phase 4 is something called as a sustained human to human transmission, or what local or in local terms which we use is called community transmission. Phase 5 to 6 of 5 is a widespread human infection, which is very difficult to stop in that case. And post peak will be the possibility of recurrent events, which the graph of Italy shows that there is post peak, there are infections which can come, and in the post pandemic stage, there is a disease activity at seasonal level. Always when you're writing an answer, you should always try this triad. This triad is very important, which fact causes the agent, host, and the environmental environment. So what are the agent factors which are linked to the cause of disease? This is orthomyxoviridae. It's a virus of the family orthomyxovirus. There are three virus subtypes, type A, B, and C. Their viruses are antigenically distinct. That means if you develop a vaccine for influenza A, give it to people, they will be protected only against influenza A, not influenza B or C. Understand? There is no cross immunity between them. So if you are infected with influenza B, you can also be infected with influenza C or A. The influenza of A and B viruses, which are responsible for epidemics of world throughout, humans are generally infected with subtypes of H1, H2, H3 viruses. This is just an colorized transmission electron image which are recorded from PIHL CDC, depicts the number of H1 influenza virus particles. You can see that the surface proteins are located on the surface of the virus are shown in the black color. So the surface proteins. Yeah, so I think this concept is very well covered in microbiology. What is meaning of antigenic shift and antigenic drift? So pandemics are caused because of antigenic shift, while drifts leads to most of epidemics. But when there is a sudden, complete, or a major change, it is called as a shift. When there is an antigenic change is gradual over a period of time, it is called as a drift. So antigenic shift will occur result from genetic recombination of various humans and animals or avian virus producing a major antigenic change. While antigenic drifts will involve only point mutation in a gene allowing to selection pressure immunity in the host population. Antigenic shift is mostly images called a major epidemic or pandemic, mostly involving all age groups. The antigenic changes occurs to lesser degree in group B influenza viruses. So B influenza virus are less to cause pandemics.